Welcome to our webinar. My name is Charlotte and I am the Industry Development Manager from Simtech. So if you have any queries during the course of the webinar, feel free to click onto the Q&A button at the bottom of the screen and you can post your questions there. Alternatively, after Dr. Lin Wei's presentation, you can still raise hand and ask questions. So without further ado, let's welcome Dr. Lin to share about his course.
Okay. Very good morning to everyone. You can see my screens, right?
Yes, can.
Okay. So basically today, what I'm going to talk about is that first of all, talk about the motivations, why we want to do this precision machine design, and also what's a precision machines per se, and then I will introduce our training program for this particular subject. Actually, the precision machines can be considered as a kind of a complex equipment, right? And then complex equipment is a part of the so-called the products, right? And being manufactured by this industry called precision engineering, right? PE. So under precision engineering, we have the not just the complex equipments, but also the precision components, right? As you can see on these slides. Precision engineering actually is a very important industry in terms of able to enable the various of the other industry, right? Because, for example, in the electronics, for example, in the industry of oil and gas, right, and the aerospace, basically you use equipment, you use machines, and as well as you use a lot of precision parts. So all these equipment and machine and parts actually are manufactured in this precision engineering, so-called factory or workshops. Actually, precision engineering is very important to Singapore, as I mentioned, right? Actually, the government putting a lot of efforts in developing and sustaining this industry, right? And then actually this is part of the manufacturing industry, right? And then the government still want to maintain a heavy percentage of this GDP, right? For the manufacturing industry. In fact, they want to maintain about 20 to 25% for the years to come, right? And also, right, and then for this PE industry, there are quite a number of firms from the SME to MNC, right? 2,700 company actually they produce those components and equipments that I've just shown. And then one of these so-called Singapore quite proud of is that Singapore is actually is a big a producer of these semiconductor equipments, right? We have applied materials here, we have K&S here, right? And some of the others. Actually also has ASM or ASML right here. They are all producers of these semiconductor equipments, right? In fact, Singapore accounts for 20% of the world's global semiconductor equipment output, right? And then this ITM stands for Industrial Transformation Maps, right? The government launched it in 2016. That means that they want to have this program that put a lot of so-called monies, and then also want to not just like upgrade the capabilities of those companies, but also putting in a lot of training, right? And then not just sustain those industry that Singapore is very strong at, but they also want to develop the new area, new industry such as robotics, additive manufacturing, advanced materials, sensor, laser, and optics. So what is this key capabilities that you want to develop this complex equipment or high precision kind of equipment? Mechatronics, actually, a lot of you heard about. Basically, This is something that it combines both the mechanical engineering and control and software, right, and sensing, basically, right. In order to achieve the optimal performance of these equipments, you need to have all these so-called the disciplines that work together to create some equipments, right? Here, I just shows that not just those semiconductor equipment, right? Why I say semiconductor? Semiconductor equipment actually is a very representative in terms of precision equipments, because you really need to achieve those high precision products, right? Of course, integrated circuit is one example, right? So you want to achieve that kind of high critical kind of dimensions, right? You need to use those back-end equipments, right? Such as those wire bonder, right? Packing machine, but also front-end equipment such as the steppers I shown here, right? The wafer steppers machine. Actually, the wafer stepper machine is the optimal as high precision machines in terms of the precision that it can achieve, right? Because the critical dimension they can achieve is in the level of nanometers. But also they need to move very fast, right? Because they need to turn out these wafers in high production rates, right? And yes, this precision equipment is not just, okay, mechatronics is not just to achieve that kind of high precision, high speed, but in terms of not so so-called high precision, high speed are those, for example, the robots, right? We're talking about, for example, the robot it shows here. We call it data robots. Basically, it can achieve very high precision kind of motions, and then to very simple kind of robot, Cartesian robot, XYZ, right? 3D freedoms, right? So it all involve to build a very high performance such a kind of robots, right? We need to have a very good so-called mechanical design, specifically in terms of precision machines, the kind of so-called the knowledge, right, fundamentals, right, to achieve the kind of high precision, high motions. Right, as I show you, this is a combination of good mechanical system and control systems. Okay, so I think some of you may be involved in some kind of machine design, right? In terms of machine design, but basically the first things is want to achieve the functionalities, right? But the functionality is not enough, right? How do we achieve the machines actually, they can be very stable, or at the same time meet the high performance requirements, right? And then this requires a fundamental knowledge. A lot of time, they say that actually I just want to so-called achieve the high tolerance kind of parts, and then I can put at it, right? When it's not stiff, right? I just make it stiff by putting more kind of supports, right? Or you want to put more weight, right? And then the thing still vibrates. So why is that? So this is required really the fundamentals knowledge in terms of these precision machine designs. Right. So here it just a kind of elaborates. So what actually can achieve high precision? So here I just shows that you want to, because machine is a machine, basically involve different kind of parts you want to assemble together, right? Because you need to have some kind of motions, right? So how do you actually constrain the parts? How do you join the parts such that it doesn't give you those kind of stress? Because stress basically involve, basically they can affect the stability of the machines in the long term. Basically, maybe at the start the machine behaves well, but in the long term, right, the machine become not so stable, right? Maybe its shapes deform, right? So this is something related to how do we design a machine so that we can have a minimum kind of internal kind of stress due to the constraints of different parts, maybe stress also due to the dynamics, right? The motions that the force that introduced internally, right? And also the stress due to this the temperature changes, right? If you want to achieve that kind of high precision, you really have to take care about the error due to the kinematics, like the statics, and then error due to dynamics, and then error due to the thermals. So this is related to the fundamentals of our machine design, right? So we have so-called, you want to design the high precision machine, you really have to take care about the fundamentals. So what are the considerations, right, to achieve the kind of stable, high precision kind of machines, right? So these are the things that really designer need to have. First of all, of course, is the constraint, right? Want to achieve the exact constraints. And then, as I mentioned, a machine is a machine. Basically, it involves kind of motions. I want to achieve high precision motion. So here I just fundamental to all, whether it's a robot or wafer steppers. Inside that, then you have that kind of motion stage, right? Whether it's 2-axis, 3-axis. So here I just use an example, right? So you want to achieve that kind of XY kind of motion. Basically, you have to take care about those design. For example, you want to achieve the kind of deterministic designs related to the constraint I just showed, right? And then you also need to achieve the kind of, in selecting the components, you have to know how to do the error budgeting, right? Because the various of these components that basically the error will accumulate and it will affect the overall errors, right, in the machines, right? And there are others like dynamic stability I already mentioned. And then also, right, you have to taking care about the whole so-called the dynamic characteristic of machines, right? You don't want to design some kind of machine such that the natural frequency, those natural frequency that is coincide with your control loop, right? So these are the things that we want to work closely with the control systems. So here is just an example, right? Kind of so-called high precision, high speed kind of XY stage we have, right? We make use of the design principles, right? We want to achieve that kind of deterministic kind of motion, right? So that we can minimize the so-called uncertainty, right? We want to achieve high repeatabilities. Of course, you want to achieve that kind of high accuracy, then you have to use the compensation, right? The closed loop controls. But first of all, right, we want to reduce those uncertainty, right? That means that we want to achieve the repeatability as high as possible. Right. So okay. So this one it just shows that. So it reduce the uncertainty, right? So the skill you need to use basically you want to achieve, for example, if you have some kind of guiding system, right? And then you want to achieve, you want to reduce the friction, right? And then one of the guiding system maybe is a kind of fractal mechanism. So basically, fractal mechanism, you don't have that kind of frictions, right? And then you need to have a direct drive, use of the linear motors, right? And then want to achieve that kind of high stiffness, basically whether you can use kind of parallel kind of actuations, right, instead of serial kinds of actuation. So various kind of techniques basically is related to the design fundamentals. Okay, we're talking about, of course, not everybody sees that they want to design that kind of high precision XY table, but in terms of mechanical design, right? For example, like what are the things that you learn from this precision machine design, right? The principle that apply actually can apply to others. For example, I just shown here, like you want to achieve that kind of variable kind stiffness actuator, right? So you want to have very good rotation kind of system, right? How do you reduce the offset error at the same time? Let's say that how do you reduce the friction, right? Then we can apply those flexible mechanisms, right? That we apply in the precision machine design in this high precision joints design, right? So this is just one example that how this kind of precision machine design principle can apply the others mechanical design. Yeah, another thing is about the parallel actuator robot. Basically, I was mentioning about the XY table that we mentioned. Actually, that was a parallel mechanism design. And then the kind of so-called the design, so-called the principle, we can also find out that actually they apply this kind of, for example, 3D printing machines, right? So it's the 3D printing machine actually is a kind of three degree of freedoms, right? And then the print head actually need to move very fast, right? They apply this kind of decoupling kind of or parallel kind of a mechanism, right? The technique applied to this kind of 3D printing machines. Basically, what's the difference is that instead of the one x-axis assembly carry the others, like conventional XY table, right? They use this kind of parallel kinematics to do that. So not just in this 3D printing machine, I also mentioned this data robot, right? They also apply this parallel so-called actuations techniques, right? To achieve the high precision, high speed motions. Okay, so I just introduced some of the things that the design principle, right, in terms of how to achieve the kind of a deterministic kind of design, right? So you need to have a various of a competency, right, to achieve that kind of a high precision mechanical design for your high performance machines. So what is the how do you acquire this kind of competency? So we have developed this kind of courses actually. We have been running these courses for many years, right? Every year, so we keep improving. So this is one slide shows that the one that I have been mentioning is this module 1. Basically, it's a precision machine design, right? Actually, it's one of the 5 modules under this graduate diploma in mechatronics. Right, that's mechatronics. Basically, it's more related to the precision machines. In fact, we also have another set of courses that is more automation robotics. So this is not today's focus. Okay, so for this graduate diploma, so what's that actually? If you're aware of this skills, SSG, right? Singapore Skills Futures agency. Basically, they have this accredited kind of courses, right? From the very first level certificate, high certificate up to graduate diplomas. So this graduate diploma mechatronics actually is the highest levels. So it is equivalent to some kind of a graduate degrees. So it's accredited by this SSG, right? So recognized by the industries. Yeah, I just mentioned about this WSQ graduate diploma in precision engineering or mechatronics. Basically, if someone you can finish all these 5 modules, then you can get a diploma. But of course, you don't need to take all, right? So if you are interested in this precision design for precision machines, right, you can just take one, and then at the end of it, if you successfully pass the requirements, right, in terms of assessments, then you can get this certificate, right? WSQ is their statement of attainment certificates. Right? So each module will get a certificate. Right? After you collect 5 modules, then you can get a diploma. Okay, this is just one slide shows that what we are going to cover in this precision machine design modules. Basically, is I already mentioned, right? It's the design principles, right? There's quite a number of them. They will elaborate on these kinematic designs. There's very fundamentals, not just to achieving the kind of complex equipment, but this kind of skill you can apply to others, so-called design the others machines. And then we'll also mention about those high precision mechanical components, right? And then linkage of special mechanisms and error budgeting, right? So these are the key topics that we're going to cover. Of course, this topic, okay, we have this schedule, not just those theory, but we also in the lab, basically, right? We will shows you how this precision machine design principle can be applied to our actual machine design. So we have various of labs, 1, 2, 3 labs. Right? So this is just a schedule. We are going to start this year's so-called module 1 from the 5th of May. Right. So it takes about 1.5 months 2 months, in fact, right, for these modules to cover all the 14 sessions. Each session about 3 hours. Okay, this is just a general information. If you're really interested in the course, basically this is the course 42 hours, right? Basically we conduct typically 2 evenings per week, right? And then these are the each module basically $3,000, right? For these modules. Of course, if you want to take all the 5 modules, then this is total amount, right? 16,000. But of course, it's heavily subsidized. So if you are PR, Singaporeans, or those long-term employment pass holders, then you are eligible for this up to 70% subsidies. And if you are a company, you are an SME, probably you can have supported by your companies, then you can have a 90%, up to 90% subsidies. Yeah, and then the eligible requirement generally is a degree holder or polytechnic holders. But if you don't have that kind of degrees, right, or diplomas, but then we look at the work experience, right? Whether you have a relevant work experience, so it's a case by case. Okay, so these are the further informations, right? Of course, we are open to questions, right? And then you can also get this scan it, right? If you want to have more information about these particular modules or other modules about our graduate diplomas, you can scan it and then go to our website. And then if you want to register, you just can scan this, right? And then you can approach myself and then also Charlotte. Okay, that's the end of my presentation, and then you are welcome to send your questions, whether you can unmute it, and then also you can type your question in the chat box. Thank you so much for your attention.
Yeah, thank you, Dr. Lin Wei. So if you guys have any questions, you may click on the Q&A button at the bottom of the screen, and you can type your questions inside, or you can raise your hands as well, and we'll invite you to speak. So Dr. Lin, some of the questions that I have for you are, if like a participant were to attend this course, right, are they able to also get a graduate diploma?
Yeah, I think yes. I think that's the question, because I focus on this module 1. Basically, this is one of the 5 modules that's under these graduate diplomas, right? So I think the requirement is that you need to pass these courses, right? And then the in terms of attendance, right? But also in terms of assessments, right? So if you can attend all this module 1 to module 5, right? Basically, module 1 to module 5, then you can get a graduate diploma, because this is one of these courses recognized by this industry that it can achieve that kind of graduate diploma levels.
Yes. Okay. Then there's another question on how are all the lessons held in the evenings only, and is it possible for like any lessons to be held during the daytime?
Okay, so for this course, basically we cater for those not just people like yeah, we mainly cater for those people that are they are full-time working, right? So we put it in the evening. So all our session actually is conducted in the evening for this course. Yes, so we don't have any daytime. Yeah, unfortunately. Yeah. Yes.
Okay. Yeah. Then another question is when would the course start, and when should they start to register for the course?
Okay, so actually the registration is already open, right? And then the first session will start on the 5th of May, right? 5th of May, and yes, so I urge that if you are interested, yeah, you can register early, because this is quite a course that is quite popular. Right? We have a start, we have conducted every year, right? In fact, not just Yeah, okay. You mentioned about the evening course. Actually, evening course is for public, right? For public. We also conduct in the daytime, but the daytime course is only for corporate. Like if the company, we also have the company, they want to send a bunch of people, right? So we then we conduct in the daytime. Actually, we can talk to a company whether they want to have the time will be flexible, right? So that will be the daytime, yeah. But for the evening one is only for public, right? But the daytime is schedule is flexible.
Yeah. So in a sense, like if the company has maybe like eight packs
Yeah, at
or
least
10
eight.
packs,
Yes, yes,
then they
that's
can
right.
start a corporate class with
Yes,
SimTech.
that's right.
Okay.
Thank you, thank you. Yeah, that's a good question. Yeah.
Then what about like I think for the more technical side, right? Because they're building precision machines, will there be any like uh any part where they will learn about all those like precision type of sensor kind of
Ah,
things?
okay. So for this particular module one, is more focused on the mechanical design, basically, right? And we have a module two, right? Module two is more on the control side. And then in the control side, it will mention about those encoder, basically, right? Because this is really about the machine design, how to achieve the kind of high precision accuracy. You basically need to have a good closed loop control, right? Then you have a good sensor, basically, right? The sense the motion, and then we call it encoder, right? But it's kind of where they put the encoder, things like that. And other things regarding the sensor, basically, you want to have some kind of calibration, right? Because you want to make sure that when you do this, for example, do the assembly, you want to achieve really squareness of this X and Y, right? What kind of equipment to use? So this course we also cover those equipment such as laser interferometer, right? Laser interferometer not just for assembly but also for calibration compensation, right? So if you want to achieve the kind of high repeatability, it's not sufficient. You want to achieve accuracy, then we need to do some calibrations already. Yes.
Okay, understand. Yeah. So there are no other questions. And if you guys have any questions after the webinar, you can always email or give myself or Dr. Lin a call and we can address your questions.
Hey,
Oh
Charlotte,
yes, so
while we are doing the Q&A, I'd like to release the polls to find out if the participants are interested in the program.
yeah, sure.
Polls now. And I think there's a question from the participants.
Yes, so Kelly also asked like, may I take M1 and M5? So the answer would be yes, you can take the modules, the two modules separately, and you can also sign up with us via at the same period. Tom, are
Okay.
we
Yes, yes. I know his question. Probably he checked our
okay.
website. Basically, I think M5, yeah, I also start in May. Yeah, I think it's possible. We already tried to so-called avoid the clash. So it's at the same time. Yes, you can take both at the same time. That's right. Yeah, I don't think there's any clash. We will try to
Try to arrange the schedule
yeah,
such that
yes, yes.
everyone can attend.
Yeah. Yes.
Yeah.
Yeah, thank you for your question. Yes. Yeah, they both start in May. Yes. Then it's faster, right? If you really want to take the whole diploma, then you have to wait until, yeah, I think the timetable is there, right? The module 2 probably a little bit later, right? The module 3 and module 4, right? You don't need to follow the sequence, basically.
Oh, so they can start with module 1, module 5. Then after that, for the subsequent modules, they can complete it later and everything can be done within like maybe less than a year.
That's right. That's right. That's right. Yeah, that's right. Yes.
Okay.
Yeah.
Yeah.
Yeah, and then please fill in the questions, right? And then if you have any, yes, so-called, yeah, feedbacks, any questions, yeah, you can. Yeah, and then yeah, so you can also email to us.
And not to worry, we'll also send the slides from the sharing today after the webinar.
Yeah, for those, yes. Good.
Mm. Okay.
Right. So, okay, if there's no more questions from the participants, then I think we'd like to close the webinar.
Mm.
Right. Thank you so much, everyone, for attending. I hope you got questions answered. So, if you have any further questions, please feel free to contact Charlotte or Dr. Mingwei. Right. Thank you, everyone.
Thank you. Thank you
Thank
for your attention.
you.
Bye bye.
Okay, bye-bye.